And let's see, make sure everything is good. Maybe it's better, it's worse. There we go. All right. So in this problem, someone named Emily invests $250 a month for 5 years into an account earning 4% interest. Remember, this is the savings plan formula that we had, and it's not really a formula that you're going to have to memorize or that I memorized. But so just to recall what it was, we had this ugliness 1 plus API over n. I really don't like this formula. Ny minus 1 over APR over n. Right, so that's what we had. After 5 years, she leaves the money without making additional deposits. So maybe she lost her job or something. And then it's left there for 25 years. So that's a decent amount of time. How much money will she have in the end? And so again, just to set it up, she's depositing money in for 5 years. She forgets about it. Maybe she dies. And I mean, I guess I didn't write that she dies. Maybe she dies. And it goes to her like niece or something. It's like an Eleanor Rigby situation. And yeah, so we're going to see how much is left. So let's first compute how much is in it, right? Because it's going to be a two-step process. The first step, we're going to use a savings plan formula to compute how much she put in the account over these 5 years. Then we're going to switch from the savings plan formula to the compound interest formula, because after 5 years, it ceases to be a savings plan because she's not putting money in, and it just becomes simple compound interest at 4% monthly. All right, so there's two parts. The first part, as I said, we're going to use this formula to find how much is in it. Then we're going to use that as a principal to do a normal compound interest formula problem. But let's see. So 250 bucks is my payment. So, and again, A is the amount in the account after Y years. N is the number of times per year you put the money in the account. So if you put $250 in your account monthly, then N is 12. Remember too that N corresponds to the number of times the account compounds yearly. So they have to be the same. And that's I think that's it. That's everything. Oh, and APR obviously is APR. So 250 for the payment, and then 1 plus. Let's see. So APR here was 4%. Oh, I didn't. It's not very clear to me. Earning 4% interest, compounded monthly. I'm going to take the 4 to my APR. Right. I guess you could read it though. I guess you could maybe read it as 4% monthly, but then you'd have an APR of like 48%, which is crazy. So it's got to be that for the APR. I mean, it's not impossible, but it'd be insane. I don't know. Maybe stock market things have that much return, but anyway. So 4 over, and everything's monthly here. So 412, and then n is 12. So that's 12 in the exponent. And as I said, we want to do it for 5 years because she's only doing the savings plan thing for 5 years. After that, she ceases. Maybe I don't know, she gets sick. It's very depressing. And so 12 times 5 minus 1 all over 4 over 12. Right, put that in parentheses. Doesn't really matter. All right, and just like before, it's some kind of long computational problem. So let's see what we get. 250. Well, I'll do it at the end. So I'll do the top first. So I'll do 4 divided by 12 plus 1. Oh, it's 4%. So it's 4%. So it's 0.04. We're going to say that's huge. 0.04. My bad. Sorry about that. So don't forget, like I just did, that your APR, when you plug it in, you want it as a decimal. As a decimal. So that's equal to 0.04. All right. All right. You would have learned, if you continued in that way, you would have found that it couldn't have been possible because you would have gotten a huge number, like so much bigger than that would make sense. So let's try that again. 0.04 divided by 12. That's better. Plus 1.
If you got lucky, it could be possible.
You'd have to be very lucky. It would be a weird sort of account. Like maybe you run a casino or something. I don't know. I don't know. Again, some things are that lucky.
I am not. I'm the opposite of luck.
Me either. I I would not do anything with the stock market myself because I would lose all my money. Uh, you're like, oh yeah, tacos sound great. I'm gonna invest in tacos. So 0.04 over 12 plus 1, and then 12 times 5 is 60. So to the 60th power, that's a big number. But that's basically, again, so it's 60 because you're doing 12 of these things, compounds and what are they, investing of 250 bucks over 5 years. So overall, there's gonna be 60 of these kind of things occurring. So that's why it's 60. And then minus one, you get something like that. And then divide it, so that's the whole top. And then I'll divide it, and the bottom will be 0.04 divided by 12. And we get that number. And then times 250. So it's, if my calculations are correct, it's 16,574 and 74 cents. And you can check that if it makes sense, right? So you're doing 250 a month for 5 years. So 250 times 12 times 5. So just right off the bat, without any interest or anything fancy, if you were just to save that money like in a sock drawer, you would have 15 grand, right? So putting in an account with some amount of interest will give you about $1,500 more. But it's always good to double check to see your computation makes sense within the problem. Like if I had done this computation and I found that if I had put my money in my sock drawer, I only had $1,000, then something would probably be wrong unless your APR was crazy lucky. But again, in this case, 4% isn't, it's high, but it's not super high. All right, so we're decent there. So after 5 years, she has this much, 16,000 some change. And now again, maybe something happens to poor Emily and she doesn't need her money or she just forgets it. Maybe she has a disease and she's I don't know, maybe she's sickly and she can't access her money. And then she dies 25 years later and it goes to her family. She has no immediate family. It's a close cousin in Pennsylvania. I don't know. Anyway. So now we just do simple compound interest. So my principal here, so this is like step one and step two. It's a two-parter. And then my principal for the next one will be how much I had at the end of my savings. So P naught equals 16, I don't know, 5, 7, 4, 7, 4. And then everything else is the same, right? My APR is still 0.04 or 4%. And then my N is 12 because things are still occurring monthly and that's it. And then, oh, and it's for 25 years. Right, so let's see. So you plug it into our favorite formula. A equals P naught 1 plus R over N, or I should do APR over N to the NT or Y, doesn't really matter. And so we plug it in. So it's 16,574 and 74 cents. And then 1 plus, and that's 0.04 over 12 to the 12 times, it's going to be huge, 25. We're going to have a decent amount of money. All right, so let's see what it is. So 16,574.74, and then times, I'll just, I always like to do it the other way. I'll do it that way, 0.04 divided by 12. And then plus 1. And then to the 12 times 25, I don't know what that is off the top of my head. I guess I should. It's going to be, what, 300? So 12 times 25. All right, so whatever that is. That's huge, right? And then times 16,574.74. That's quite large. Yeah. So you have 44,979 and 95 cents. That's quite large. I think everything is correct though. Oh, and what was 12 times 25? Hey, all right. So, yeah, so if you leave it there for 25 years at 4% interest, you will just about triple your money, which is amazing. All right. So any questions? So her cousin or niece or whatever gets a healthy chunk of change from the aunt she didn't know she had.
So number one is us doing the money that she's put in there, and number two was when the distant cousin took it out.
Yeah, exactly.
Between 5 and 25.
Yeah. So this is in the first part, that's when she's actively putting money in. In the second part, this is when it's just sitting in the account gaining interest, but no more money is coming in. That like of her own. Yeah. The only money coming in the second part is the interest that you're generating because it's sitting in the account year after year after year. And 25 years is a decently long time. All right. Any other questions? All right. Cool. So it's kind of fun problem using both parts. But move on. So today, as I said, we're talking about payout annuities and loans. I did Google what an annuity is. It's something that you pay money into, I think, or something. I don't know. It wasn't a clear definition. But everyone knows what a loan is, so that's easier to understand. And it will turn out that payout annuities and loans are basically they're very similar, except they're opposites. So we'll see. Anyway, let's do an example to kind of try to understand what's happening, and then we'll have a comparable formula. So you have 150,000 in an account with an APR of 5.2% compounded yearly. Every year you take 35,000 out of the account. How many years will pass until the account is empty? All right, so let's try it. And so what we're going to do is, we don't have a formula, but I'm just going to make a table. All right. And so let's just see kind of what the setup is, right? So again, I have 150,000 and I have an APR of 5.2% compounded yearly. So it's at the end of every year. And then every year you take out 35,000. So let's say at the start of every year, at the start of every year, you take out 35,000. And then, so again, so like what this says is that like, if we take it out at the start, maybe January 1st, we take out 35,000. And then let's say the interest is compounded right at the end of the year. So like December 30th or something, 31st. How many years will pass until the account is empty? And it's not going to be a perfect situation, right? Like, because 35,000 won't perfectly go into it. At the end, we'll have like a little bit of change left, but it'll be fine. We'll see what happens. So let's just do year by year. So at year 0, so that's like, beforehand. So we have like a year and then amount. I could do interest. Right. So at year 0, that's starting off. I have 150,000. Right. And no years have passed, so I'm not gonna do any interest. Let's do year 1. So all right, because again, year 0, that's just the starting point. I probably should have started at 1. Year 1. So I have 150,000, and at the end of the year, the interest is computed. So we can do 5.2% of 150,000. And it's just yearly. So there's no monthly thing happening. That we don't have to divide the APR by anything because it's just at the end of every year. That's all the interest you get. So 150,000 times, and it's 5.2, so 0.052. So we get $7,800 in interest. All right, this might take longer than anticipated. 7,800. We'll see. If it takes too long, we'll quit and call it. And then you subtract off 35,000. So we gained 7,800, and then the amount we started with is 150. So, oh, I guess I forgot to take out the amount too. Shoot. Let me do this again. Sorry about that. Let me fix this. So I forgot to take out the 35,000. So 150 minus 3,500, 35,000, and now times 0.052. There we go. So 598. 5,980. All right, there you go. So minus 35,000. There we go. All right, so in year 2, we have this much. So what was that? 115,000 plus the 5,980. So 11500. So we have 120,000 at the beginning of the second year, but we take out another 35,000. So we have 85,980. Right. So 85,980. And again, all this is just an example. So all this really depends on how you set it up. It depends on when you take out the interest or when you compute the interest, and it depends on when you take out the money. So if you could do it any way you wanted to. Like order-wise, you could take out the money after you get the interest, depending on the bank. There's a lot of variables, so this is just a very particular situation. Anyway, so 85,000 at the beginning of that year, and now we compute our interest. So let's do times 0.052, and we get 4,470 and some change. 4,470 and 96 cents. All right. And now for year 3, I had this much. So I add the 4,400. So plus 85,980. But I take off my 35,000 that I'm like living on apparently. So minus 35,000. So at the start of the third year, I have 55,000, give or take. 450 and 96. All right. So I've taken out my 35,000 and now I compute the interest. So times 0.052. So my interest, you know that taking out this money really reduces my interest significantly. It started off at, $6,000 and now I'm down to less than 3. So 2,883. And it doesn't matter, 45 cents. All right. So we'll get there shortly. I think just next year or two. All right. So now the next year, I take my interest, add it on. So plus 55450.96. All right. And so that's what I have the next year. But then at the start of every year, I take out my 35,000. So minus 35,000. So at this year, I have 23,000 something. 23,334 and 41 cents. All right. Now that U goes past and you compute the interest, the 5.2%. And then you have just over 1,200, so 1,213 and 39 cents. All right, and now we're done because at the beginning of this year, I have the amount from my previous year plus the interest from that year. So I have plus 23334.41. So at the beginning of this year, I only have 24,547 and 80 cents. And so I can't take out my 35,000, so done. All right. So again, so we started off with 150,000. The 0th year, we didn't have any interest. The first year, I took off my 35,000. I added my interest from that year. I guess I could have had interest. It doesn't matter. As I said, the important part is just that we kind of get what's going on, not necessarily the particulars of this setup. I computed my interest. I added that back on to what I had left. And then you just kind of repeat. So you compute the interest, add it back on, compute the interest, add it back on, compute the interest, add it back on. And all the while you're taking out 35,000. All right. So this is something you do like if you had a retirement fund. Like suppose you saved up 150,000 for retirement, you would obviously need more than that. But suppose you saved up that much money for retirement, and then every year you took out 30,000, 35,000, whatever you wanted. Yeah.
How come 4 is smaller than 5?
Oh, because I added the interest back on. Oh, you're right. Oh, it's because I didn't take off the 35,000 because I couldn't. So this is I can't take out 35,000 from here. For the other ones I did. I think I took off too much on the first one, but don't worry about it. Yeah. So at the last year, I couldn't take out 35,000 because I didn't have enough money. I would be negative. You could just take out the whole amount. So you could put 0 there if you wanted to. But, and I think I made a mistake here. I think I did it twice somehow, but it doesn't matter. Again, just kind of keep in mind what we're doing. We're taking out 35,000 and then it generates interest. Next year, take out 35,000, generates interest. And this is the kind of account we want to study a little bit. And so luckily, instead of doing this kind of ugliness with interest, and this is the simplest case where like it's compounded yearly. If things are done monthly, it's much more messy. So luckily there's a nice way to do it. Let's see. So in any case, this is an example of a payout annuity. Right. And as I was saying, the purpose of payout annuities are basically just retirement related things mainly. You have like trust funds are kind of like that too, where you have a big sum of money and over time you're paying out, you're taking out portions for yourself. These aren't loans, right? You're not, I mean, they could be, as you'll see, but you're not paying, this is just like coming, you're pulling it out yourself. You're pulling out the 35,000 or whatever it is every month or year or whatever the setup is. And all the while it's generating interest because it's really just sitting in an account in a bank. So it's really nothing other than just simple or just regular compound interest, but you're taking money out. It's exactly the opposite of what we did here with the savings plan formula. With the savings plan formula, you have a regular compound interest account at a bank, and you're putting in money on some basis. Here, we have a regular compound interest account in a bank, but we're taking away money at a regular basis. So that's the difference. All right. Anyway, and as I said, there's a nice formula. So as I was saying, you can keep, when you think of these, think of them in terms of like savings accounts. It's like just the opposite end of the coin. So PMT, wait. Yeah, maybe here's this. PMT equals, so again, PMT is the payment that you want to take out or that you are taking out, equals P naught. So P naught's the principal, the amount that you start off with in the account, and then times APR. I think this is, if you're following along in the book, I think they phrase this in a slightly different way, but it's the same formula. And then in the bottom, I have 1 minus 1 plus. It's a little ugly. It's just like the other one. I hate it. APR over N to the minus NY. All right. So, yeah. So this equation needs a little explanation. So APR, as you probably would have guessed, is just the APR of the account. Because again, it's just both of these, this and the savings plan, are just regular bank accounts. And then N is the number of times that you're taking away money. So I guess I can put that. So N equals number of times per year money is taken out. And just like with the savings plan formula, it's not only the number of times the money is taken out, it's also the number of times it's compounded. Right. What else? PMT is the amount of your withdrawals. So amount of withdrawals. And then P naught is the amount in the account at the beginning. P naught equals initial amount in account. All right. So it's a little bizarre. But let's see. So, and I think this example will help kind of show how to use it. So after retiring, you want to be able to take $50,000 every year for a total of 25 years from your retirement account. The account earns 7% interest. How much will you need in your account when you retire? So where's my other example? So like in that example we just did, here we are. Just like I said, you could think of this like a retirement situation where you're taking out 35,000 every year. And so this question here asks you, if you want to retire for 25 years, if you want to plan to have that much money, just in case you live 25 years, then how much will you need to save up initially? So what we're going to do is kind of like the same strategy we employed with the savings plan formula. We're going to identify everything we know. We're going to plug it in and just solve what we don't know. All right. And labeling things should be relatively self-explanatory because we've done this a few times and the variables haven't really changed. So you want to take out $50,000 every year. So that's my payment. That's the little difference in this formula here. PMT is the amount you're taking out. So my payment is going to be 50,000. I want to do it for 25 years, so that'll be my Y. The percent is obviously my APR. Again, we want that as a decimal, so 0.07. And then I think everything's monthly at retiring. Here I should say monthly. Compounded. Oh no, it's every year. Sorry. That's what I'm saying. So this is the one weakness of this formula, just like the savings plan formula. Um, so you want to take out the money every year. So since it's every year, my n will just be 1. So that's the weakness. So you in this kind of situation, you generally want things every year, but oftentimes things are compounded monthly. So you'd have to kind of rewrite some things if you want to change it into a monthly situation. So like what you could do is you could say, oh, so I want $50,000 every year. So my monthly salary then would be about $4,166 or 67. And so you could use that and kind of can translate things into a monthly basis. And that should work too. But we'll stick with what it has here because it doesn't really say. We'll say it earns 7% interest every year. Okay. So let's see. So I plug everything in. So PMT is that I want to be 50,000. And then my P naught, I don't know, right? I want to know how much I need to save up. That would be my P naught. My APR was 0.07. N was 1, as I said. 1 minus 1 plus. And so I'll show you a little trickiness here, but 0.07 and then over 1 again. And so be very careful here with the negative. So it's to the minus, and then N was 1. So it's 1 times 25, which is this minus 25. All right. So let's see. So what I'm gonna do is I'll compute everything. So it'll be $50,000 equals P naught times something, and then I'll just divide both sides by that something to solve for P naught. So let's start with the most complicated looking bit down here in the bottom. So 0.07 plus 1. I guess we could have done that in our heads. Anyway, now it's 2, and it's negative. So be careful. If you're using one of these, down here is the minus button. So minus 25. If you're not using one of these, be very careful. If you're using a scientific calculator, be wildly careful, because these are slightly tricky. This one and the savings plan one are slightly tricky formulas to plug in things to. So if you're using a scientific, I might even say that you could do parts of it individually, write them down, and just round carefully as well, and then do it in pieces by writing down partial answers, if that makes sense. So like maybe I would do this thing first. So I would do that, and then I'd write that in for that. So I'd have 1 minus 0.18425 or something like that. But yeah, these would make it difficult, make your life even more difficult. Anyway, so I have this, and then 1 minus, and then second answer. All right. So the bottom is that. So maybe I'll do P naught 0.07 over 0.81575 maybe. Right. Cool. All right, so now I have $50,000 equals this. So I guess I can do a little more. So now I can do 0.07 divided by second answer. And so I get P naught times 0.08581, yada, yada. Okay. And now I can divide $50,000 by that number to solve for P naught. So 50,000 divided by that. So my P naught equals this, what is it? It's like $500,000. $582,679.16. So I need to save that much in order to take out 50 grand for 25 years. So what is 50 grand for 25 years? 1.3 million. That's a decent amount of money. So the luckiness here, the reason there's such a discrepancy, I think, is because it's 7% interest. 7% interest is a lot. So that's probably why you only need $50,000 or $500,000. The other thing I want to mention too with this problem, and just with using a calculator in general, is I don't know if you're familiar with the answer button down here. So So like here, $50,000 divided by ANS. If you have something like here, I have 0.0858, whatever, and I had computed that already. And instead of rounding it or writing it down and typing a rounded version back in, you can always just do second and then answer. And that will just plug in whatever the calculator previously computed. So if you're not familiar with that, it's sometimes useful. But anyway, any questions here? Cool. Oh, and I guess so. Look, this is kind of interesting too. So I have 5, 8, 2, 6, 7, 9, and now if I take 7% of that, I get $40,000 and $41,000 essentially. So what that tells us too is that if this is my principal, and I get 7% interest, then I'm already making every year. I'm making $41,000 just in interest, and so that's kind of why it works, I think, because every year you're generating almost as much money as you're taking out without doing any more work. So I don't know. It's always good to look through your answer and kind of prove to yourself that it's the correct one, even though you should be theoretically. All right, so let's move on. Let's see. You will have $500,000 in your account when you retire. That'd be nice. You want to be able to take annual withdrawals from the account for a total of 30 years. Your retirement account earns 8% interest. How much will you be able to withdraw? All right, so let's see. So let's go back to our formula. And again, like I said, you have this general formula here. You can plug in anything you know and solve for what you want to know. And so that's basically how you do all these problems. So let me rewrite it. So PMT equals P naught API over N all over this ugliness 1 minus 1 plus APR over N minus NY. Okay. So let's see what we have. So this is our principal, the 500, $500,000. My principal. That's how much I start with, right? And you want to take annual draws for a total of 30 years. So 30 years is my T, or my Y, sorry, whatever you like to call it. 8% interest is my APR. And how much will we be able to draw each year? So this question, it's kind of the opposite of that one. This one, I know how much I'll have at the end, and I want to know how much I could withdraw, assuming I'll live 30 years. Just, I don't know if that's a safe assumption when you retire. But anyway, it works the same way. You plug in everything you know. So my payment, I don't know. I don't know my payment. That's what I want to know. Everything else I do know. N will take to be 1 again, just for simplicity. We'll take N to be 1. You could do it 12, but yeah, it's okay. And yeah, let's see. So PMT, I don't know. Everything else I do. So this one will be less work because we know everything on the right-hand side. So 500,000 times 0.08 over 1 all over 1 minus 1 plus 0.08 over 1 to the minus 1 times 30, so minus 30. Close parenthesis. And again, just be very, very careful. Let me put it like, there you go. All right, so I'll do the bottom first. So 1.08 all to the minus 30. So I don't know, I like putting parentheses around that. It makes me uncomfortable otherwise. I get that. And then again, so I'm gonna do 1 minus, so 1 minus keys, and then I'll do second, and then the answer key is the negative sign of mine on the bottom, but second to get the answer. All right, and so that will give me this whole thing here on the bottom. Now I can do 500,000. One more? Yeah, it's enough. Times 0.08. So this is the top. Divided, again, I'll do second answer. Boop. So I get $44,413.72. So, you don't have to do it like that on the calculator. You can do it much more piecewise. You can do little bits and snippets and plug them all together at the end, and you should get the same answer, give or take some change because of rounding. But yeah, so this is how much you'll have every year assuming you get 8% interest. And I should note too that when you're doing this, uh, at the end of 30 years, you'll have nothing left. Like I believe this is taking the way this formula works is that it's taking out uh, what in this case it's 44,000 every year, and it's taking out the most it can. At the end, you'll have a zero balance, right? So it's kind of good and bad, I guess. It's bad in the sense that if you're towards the end of your retirement, you won't have any money left over in case you want to have like I don't know, an estate or something. Anyway, so that's those are payment annuities. As I said, most of the problems you'll see, especially if you read the book, if you do other things online, they're all going to be retirement related. But the other application is loans. So it turns out that and we'll do this example to kind of demonstrate that, but it turns out if we look at this from the opposite direction, that it's just a loan that you're kind of paying. It's just a loan. So let's see what I mean. So you take out $1,000 loan with an APR of 12%, so 1% monthly. So this one is monthly. So say we pay off $200 every month along with interest. How long until we pay off the loan? How much total will we pay? So let's do this one like we did the other one, that first problem we did. Let's write it all out. This one won't be as bad, I don't think. I think it takes 6 years. So year, let me just, I got my chart too. Here we go. All right. Oh, sorry, months, not years. Month. Put months there, balance here, and then I'll do end of month, balance, and then interest. All right, so month, 1, 2, 3, 4. I think it takes 6. I don't find out. So you take $1,000 loan. Oh wait, it's the wrong one. Okay, just a second. Did I have it? It's okay. It'll work out the same. So save $1,000 at the beginning, and you pay off 200. So I'll say 1,000 minus 200, right? Because we're paying off the 200, and then the interest. So the interest from that first month. So it's what is it? 1% monthly. So it's $1,000 times 0.01. So the interest is $10. So you're paying off the $10 as well. So it's minus 10. All right. So the next month I have 800. It's not that many months at all. And the next month I have 800, right? Because again, I paid off all the interest from that month during that month, along with the $200. So the interest the interest will appear, and then I'll pay it off instantly for that month, and it will go away. And so the next month I kind of have a clean slate. So that's why it kind of looks sort of neat. Usually, if you didn't pay the interest off, it would kind of get ugly, right? You'd have interest, and the interest would go down, but you keep adding it, and it grows. Anyway, for this month we do the same thing: 800 minus 200, and now the interest on 8. Again, we just do 800 times 0.01. So it's $8. Interest month $8, but I minus $8. I'm always paying off the interest. So you kind of see a pattern, right? So 800 minus 200 minus 8. And again, the interest is added on, but okay, so 600. So like, I guess this should really be 1010. This should be 808, but it's okay. You kind of understand, I hope. And this month we do the same thing, 600 minus 200. And then the interest on the 600 is $6. So it's minus 6. So the interest that's added on is just instantly cut. We don't even, it's gone. So next month's 400. We do the same thing, 400 minus 200 minus, in this case, the interest is $4 because 1% of 400 is 4. And so again, the interest is added on for that month, but before it even counts, we pay it off right away. So we're down to 200. So it's 5. So we do 200 interest this month is $2, but we pay it off with the rest of the money. So it's 200 minus 200 minus 2, right? So we paid off everything. So we have 0. So it takes 5 months. Takes 5 months, right?
Why don't you just divide like the 1,000 and the 200 and it would give you 5?
Yeah, you
And you
could do
ignore the
that.
interest?
Yeah, but what's a little tricky is it's only that simple in this case because we pay off the interest every single month. If we weren't paying off the interest every single month, it gets a little more difficult. Here, it would still take, it would be just, I think you would just get slightly over 5 months if you didn't pay the interest off, right? But yeah, in general, you can just divide it and you'll get an approximation. Here, it works perfectly just because we're paying the interest off. Now, what is also interesting is overall, right? How much did I pay, right? So overall, I paid $1,000, which I put on my card. But I also paid all this interest off along the way. So what is that? This is 10, 20, $30. So this is my interest. This is my principal. So overall, I paid $1,030 over 5 months. Right? So you do have that interest, but it just really works nice because we're paying off that $30 as we go automatically. But what I wanted to show you about this problem is that it's kind of what we just did, right? So like you can, if you kind of take out this prompt, the example prompt, you can think of this as I have $1,000 in my account, and every month I'm taking off $200. So you can kind of think of a loan as a payment annuity, right? So a payment annuity that we talked about earlier, we're like retirement accounts, so we owned the payment annuity. But here, for a loan, like paying off a loan, someone else owns the annuity, sort of. So it's just it's kind of flipped. They're the same. We're doing the same operations. We're taking out money, but instead of taking out money in an account that we put money into, we're taking money off of a loan balance. But the operation still works the same. The loan balance is getting interest, just like our payment annuity got interest. Everything really works just the same. So the formula that I had earlier for the payment annuity will also work for loans, assuming you interpret the variables differently. So yeah, so does this seem familiar? Yes. So the loan payment formula is the same as the payment annuity formula. All right. Oh, and I guess I already rearranged it for the payment annuity formula. Doesn't matter. It's the same thing though. So I'll rewrite it just for reference. P naught APR over N. All the variables basically mean the same thing. 1 minus, but let me see, finish this. APR over N to the minus N. Right. So the difference here is that the payment will be our loan payment. And the years will be how long we want the loan to go for. The APR is still the APR. The P naught's the loan amount. Right, so it's like in the previous example we did, that's the P naught was $1,000. And that's it. The only, and the Y is the length of the loan. That's kind of cool. Payment annuity or loan, same thing essentially, but just different interpretations. So again, let's try to use this formula in an example. So as we have student loans of $100,000 with an APR of 6% monthly for 20 years. What's the monthly payment? All right. So this one, it's very clear everything's monthly, right? 6% monthly payment. All right. And as I said, just like with the payment annuity, just with the savings plan formula thing, the N corresponds to the both the compound number and the amount of deposits or payments or whatever per year. So they have to correspond in these formulas. So let's plug everything in. So this is your P naught, the principal on your loan. APR is obviously the APR. The 20 years is your Y, and N is 12. So everything's kind of identified already, but you just plug it in. Everything on the right plugs in, and you'll find your monthly payment, because that's how much you have to pay. And the loan payment is over, so N times a year. So if N is 12, PMT will be your loan payment per month, your monthly loan payment. If it's 52, it will be your weekly loan payment, although I don't think anyone pays a loan weekly. And let's see. So PMT, these are mostly computation. There's sometimes a little algebra to solve, but usually it's not too much. $100,000 is our payment or our loan. 0.06 is my APR, N is 12. 1 minus 1 plus 0.06 over 12 to the minus 12 times 20 years. I don't know if people get student loans over 20 years, but that sounds slightly miserable. All right, let's see. So let's see, again, we're gonna compute it. It's good practice for calculator skills, I suppose. So 0.06 divided by 12 plus 1. So this bit is 1.005. And now I'll raise that. Again, be careful of the negative. It's minus 12 times 20. So I get that, whatever that is. And then it's 1 minus that whole quantity. So it's going to be 1 minus the answer I just got. So everything on my denominator is 0.6979, right? Now for the top, I can do 100,000, well, I'll put it in parentheses because I like parentheses. 100,000, one more. And then times, and again, don't be afraid to put 20 parentheses in. You can do times 0.06 divided by 12, close parenthesis. And now at the bottom is what I found, so divided by my answer from the previous line. Right? So it's 716.43. All right. So again, feel free to do that in steps. You know, maybe I'll just show you how you would do that on this other calculator. And I feel bad. All right. So, so as I was saying, I'll do the top first. So $100,000, right? Times 0.06 divided by 12. All right. So the top is 500, hopefully. All right. And I'll do the bottom. So 0.06 divided by 12 plus 1. So that's that. And now let's see if I can do it on here. Caret. Oh, there are parentheses. So I do have.
Could you slow down just a tad? I'm trying to follow along, and doing it on my calculator and watching you at the same time is.
Oh, sure. All right. So you're good with the top?
Yes.
All right. So I'll start at the bottom then. So I'll start with the 0.06 divided by 12. All right. And that gives me this thing, whatever that is, the innermost part. And then I'll add the 1. So now that gives me the 1 plus 0.06 over 12. Now I need to raise it to this minus 12 times 20. So I have my caret, so I do caret, which is exponentiation. And then I'll do, since this calculator has parentheses, I'll do parentheses. And then it's negative. So down here, I have this little negative button in parentheses. I don't know why it's in parentheses. It's just a negative. So I put negative. Hopefully it works. And then 12 times 20. And I'll close my parentheses.
That people don't think it's a subtraction sign.
Oh, yeah, that's probably right. And I think I can press enter. Yay. All right. So I press enter and I got that. So 0.302 whatever is the whole chunk after the minus 1 or 1 minus sign. All right, so it's this whole chunk down here. Now I just need to subtract this number from 1. So I'll do 1, and this button has the same thing. So I'll do 1 minus. And then on this calculator, if you have one like it, there's still this ANS thing down here above the negative sign, oddly enough. So I should be able to do second and then negative sign, which will give me ANS, and I should be doing enter, and it works. So I'll get 0.6979, whatever. And again, so you could put that down here. So you could do 0.697903. You can round it. Maybe I'll do one more because I didn't round. 9. Right? And then so you just do 500 divided by that number. And you could type it in, or if your calculator is handy enough to have the answer key, you could do second answer again to get 716.43. Right? So it works with both, obviously, but just be careful. I really hate this negative up in the exponent because I feel like that throws a lot of people off sometimes. Any questions about that one? Cool. All right. Oh, and feel free, since we don't have an actual, we're not like meeting physically, and we don't have tests in like an actual class. Feel free to use whatever calculator you like. If you have a calculator on your phone that you really like, feel free to use that. Or if you like Wolfram Alpha or something online, like a website, that's also an acceptable form of calculator. All right. Oh, and let's just finish this problem because I guess it's almost 5 o'clock. What's the total amount paid? So this is my monthly payment, $716, and I'm paying it for 20 years monthly, which is crazy. So if I want the total amount paid, it's going to be 716.43. Again, that's a monthly payment, and that's 20 years monthly. So 20 times 12. So that will give me 716.43 times 20 times 12. It's a lot, right? It's 171,943.20. And you'll notice that the loan itself is only $100,000. So you're paying like what, 72,000 just sort of like for the privilege of taking out the loan. It's crazy. Same thing happens with mortgages. Most mortgages aren't 6% APR. Let's see. So that's your total amount. And then it says what percentage of the money is paid. What percentage of the money paid is the principal, and what percent is the interest? So let's see. So the principal, as I said, is the 100,000, right? So if you go back, we took out only $100,000 in student loans. So that's my principal. That's how much that I actually had, and everything else in my total paid is interest that I paid on top of what I actually used. So for the principal, and it says what percentage of the money. So I mean, I'm assuming that I'm taking that to mean total. What percentage of the total money? Right. I like how I interpret my own writing. Principal. So for the principal, it's just going to be, and it's going to be the percentage stuff we did. So remember when we did it's relative change. We had the new minus the old over the old. So in this one, I guess it's not really as much new, but it's the interest over the total. So it's going to be 171. Oh, sorry, this is not the interest. This is the principal. 100,000. Sorry, 100,000 over the amount. So it's 171,943 and 20, and then one is a percent, so times 100. So 100 divided by 171,943 times 20, or 0.20 times 100. So it's about 58%. So 58% of everything I paid was for the actual money that I used. Like you're taking $100,000 and you're paying back $100,000. So that money that we used is 58% of what I actually paid. And then for the interest, you just do the interest over the total. So it's gonna, I guess that's really not new. I guess it's really not relative change. It kind of is. I guess it depends how you interpret it. It's basically just percentages. So that it's going to be 171,943.20 minus the principal over the 171,943.20. This one kind of looks more like relative change, but as I said, it's like the total paid minus the principal over the total paid. But again, it's really just like you're taking what you're interested in, the part over the whole. It's just like basic fractions. So you're doing the part with the interest part over the whole. So here, It's just 7,194,320 divided by 171,943.20 times 100. So it's just 42%. You could have also just subtracted 100 or 58 from 100, I suppose. But, and yeah, so that's the ugliness of this problem because the APR is 6%. So you're paying a ton in loans over 20 years. In fact, 42% of everything you pay is just interest in this problem. Only 58% or close to 60% is actual things that you use, actual money that you use for something. And interestingly enough, I think the way it works for loans is you pay more interest first. So your first payments will be mostly interest. And as you go, the interest goes lower and lower and lower. And as you get to the end of your payments, you're paying more principal. So like you're paying, what was it, $716 every month. And so for the first few years, you're paying mostly interest, like in your monthly payments. And as you go on down the line for your loan, the amount that you're paying in interest will go down as part of your monthly payment, and the amount going towards principal will go up in your monthly payment. I don't know exactly how that works as far. I think it must depend on like the banks, but that's my understanding of how mortgage payments work and stuff like that. Anyway, any questions? So as I said, really, we're just, if you want to break it down really simply, we're just doing, today we just talked about one formula, right? We just talked about this one formula, and we talked about two ways to use it. We talked about using it in terms of a payout annuity, which is like a retirement account, and we talked about it in terms of a loan. And either way you think about it, it's exactly the same. But yeah, any questions? Cool. All right. So today's Tuesday. Tomorrow's Veterans Day. Happy Veterans Day tomorrow, if you have off of work or whatever. Yeah, I'll see you Thursday. Your test, I almost finished your test, but you'll have those Thursday too. My apologies for the delay. Cool. All right. I'll see you guys.
Hi, Matt.
Hey, Gary. How you doing?
Oh, pretty good. Did you want to? Did you have some time tomorrow?
Yep. Tomorrow will work.
Okay.
Anytime in particular you want?
Do you have